And now we have to connect the gate pulses from G1 to G1, K1 to K1, G2 to G2, and K2 to K2. Now we have connected the gate pulses. Now we have to connect the capacitor from CA1A to CA1A and C1B to C1B. Now we have to connect the RL load from R3A to R3A, R2A to R2A, and in this position we have to connect the R3B to R3B, and in this position we have to connect to the R2B to R2B. Now we have to connect our DSO in this position. From positive to positive, connect the our DSO probe. In classy mode, we have to observe the waveform in this position. Only classy commutation method. Otherwise, other commutation method we have to connect the DSO probe in this position. Only one position class C connected DSO probe at this position. Now we have to switch on the trainer. This is our output waveform of class C commutation method as per our manual. In class C method, there is a particular output waveform showing in your DSO. In this commutation method, no effect of your frequency control and no effect of your duty cycle control. There is a only particular output waveform showing in your DSO. This is our class C commutation method. Now sir, we have connected to the class D commutation method. Now first of all we have to firing selection mode change. In D and E, they both are switches in 1-1 position. Now first of all we have to connect the DC power supply from positive to positive and ground to ground. Now we have to connect the gate pulses from G1 to G1, K1 to K1, G2 to G2, and K2 to K2. Now we have to connect the capacitor from C3A to C3A and C3B to C3B. Now we have to connect the inductor from 2 0 2, and now we have to connect also the resistive load from R1A to R1A and R1B to R1B. Now we have to connect our DSO probe from ground to ground and positive to positive, ground to ground and positive to positive. In class D and E, vary the frequency and duty cycle control also. Both are variable and both are effectable, showing in your output waveform. Now switch on the trainer and this is our class D commutation output waveform, and now we have to vary the frequency control in showing in your DSO. This is your frequency control, and now selectable switch in downward position. Now we have to vary the duty cycle. They can easily show in your DSO. The duty cycle is changing. Now switch in upward position. This is your frequency variable control. Now this is our output waveform. Showing in your DSO as per our manual. Make sure in class D and class E both are like frequency control and our duty cycle control showing in your result. This is our class D commutation method, and this is our output waveform in our manual is class D commutation method. Now we have to connect the